raining the last couple of hours or like the whole night. And look how wet the soil is, right? 20% of 3 meters of rain here falls in form of mist or clouds. So the reason why is the altitude, the elevation, right? We are over 5,000 feet from sea level between both sides of the mountain range. We are close to the Pacific one. And the Atlantic one is ahead. So we're almost right in the middle of the continental divide. So the trade wind is very persistent, especially in December, right? The cold wind that you get actually at home in the United States, right? This wind moves from east to west and bring us a lot of humidity from the Atlantic Ocean. This humidity is concentrated at this elevation. So the wind condensates and then forms a bank of clouds that covers the mountain 80% of the time. Right? So 80% of the time, the weather is like this, very dark, right? So the plants and the trees develop a variety of ways to reach the light, to do photosynthesis, right? So their roots, their twigs, and their leaves have many ways to hold on to the bigger trees and reach this light up there. But where do they take the nutrients? Like, where? From the wind, right? From the cloud. In the rain, we have phosphorus, potassium, and nitrogen, okay? And the plants have microscopic scales on their twigs called trichomas. So the raindrop goes inside that microscopic scale in the leaf and leave those nutrients inside of the leaf. And the plant develops its roots, flowers, fruits, leaves, and the trunk and the stems using these elements. So those are epiphytes, like orchids, philodendrons, ferns that grow up on the trees. They have those tiny scales to take the nutrients. The ones down here have other microscopic scales called stomas and take also nutrients from the clouds, but they can take nutrients with the roots from the soil, where the nutrients are in this thin layer of soil. So two different groups. One needs the light, even more or higher percent. For example, strangler figs that reach 95% of light as possible up there to grow on top of the other trees. Or mistletoes, for example. And the other plants reach enough light down here, but reach enough nutrients on the ground. So two different markable groups of plants that we have in Monteverde. Epiphytes, hemiepiphytes, and parasites. Okay, this is the three markable groups. So today, we're gonna see, along the way, trees that are holding up 200, 300 plants on top, right? And these plants are they just holding onto the tree, but without killing it. Because if they kill it, the branch fall off, and they don't reach enough light. So the roots are attached to the outside and don't go inside their vascular systems, like a mistletoe does, right? Mistletoe sucks the xylem or trees up out of the trunk, and eventually both of them die. The mistletoe when it ends the cycle, and the branch when the mistletoe is growing, right? So that is the difference between a parasitic tree and an epiphyte. And a hemiepiphyte, like for example, those trees that grow the wrong way from the top to the bottom. Okay? Any questions so far? No? So we're right here in the middle of both sides. So the trade wind joins the Caribbean side here. The cloud starts moving up to 5,000 feet. And once the mist passes this line right here to the Pacific slope, the hot, dry air forces the cloud to dissipate. So you feel that light rain. You can actually see blue sky in town, right now, on the way up, I saw it's very clear. But once you get right here, the weather changes drastically a lot. You know, the Quakers, when they came to Monteverde in 1949, they set up mist nets on the cow's fields with the pipe below it and catch the water from the cloud and use this water for washing plates at home, the toilet, and taking a shower. Just for example of how much water falls in form of mist. So this is a tropical cloud forest, a tropical rainforest, higher elevation, and doubles the size. But the rain falls in form of like torrential rain. Here falls most of it in form of mist or cloud. Any question? No?